That was, I mean, it's been almost a month now since I took a session. I do know, but yeah, coming from India and getting sorting out a few things, so it took some time. And even this memory is not such an easy topic to digest. Like to create these demos, we need to tweak few things, which is not that easy for me. So I was just doing some things from my side, and as I promised, I will give you my best with respect to memory series. Okay, so this is going to be our first session with respect to memory, even though we did discuss few points in the past with respect to memory. So I will start it from the scratch. But instead of going with theoretical slides or PPTs, I don't want to go that side. I will do sessions that are more practical. Okay, that gives you some confidence to handle the real world scenarios. So I do have plenty of PPTs on memory, so I can just walk through them saying that this is the what can I say, file table, this is the page table, segmentation, virtual allocation. There are so many terms that I can discuss, but that is not my intention. I wanted to show them practically and see how well you can align with them, like how to handle the real world challenges with respect to memory. So that is my main intention. So we'll just go through a practical session today. And after that, I will go through some theoretical stuff. Okay. So that is my intention. So kind of reverse engineering, like we don't do practical. I mean, we don't do theoretical and then do practical. We will just start with practical and we will grab those concepts and then we will understand the theoretical concepts at the same time. Once we complete this session, that is my agenda. So I mentioned the title as resource semaphore. So what is resource semaphore and when will we see this resource semaphore and how it affects memory is what we're going to discuss today. Okay. So if you have any questions during this session, you can break me because many people told me to take all the questions at the very last. But if you take it very last, somehow I feel that we'll miss that good questions by any chance. So that is the intention. I will not prolong with my answers. I will cut short them and I will make sure that the session progresses quicker. Okay. Okay. So as I said, I don't have any PPTs for the moment. I will do the PPTs in our next class, any PDFs or something that talks about the theoretical stuff of memory. So when I say memory, so we have to understand min server memory, max server memory, AWE, address windowing extension, and a few other terms. So first I will explain some theoretical terms and then we will see them in practical usage. So first thing what I will do is I will restart my instance. Why I'm doing this, I will let you know. Before I restart my instance, I will show you one more thing. Uh, then you will be able to understand much better. Uh, when I say much better, you will be able to understand min server memory, max server memory, and the large log pages in memory. Okay. So before I do, I just wanted to see if I can explain this topic. Just give me a second. So that is called as paging. So actually, you need to understand this part to understand the complete picture of what is paging and how it works and all. If you see this, this is coming from Byju's. So even Byju's, I don't know, I am seeing this for the first time. So even Byju's looks like they are going to deal with computer science topics also. Anyways, just keep this diagram aside and we'll start our session. Before I do, I just wanted to show you these five counters with respect to memory. So let me copy this and we'll see what are those values before we restart. What is target server memory and what is total server memory? And what is this memory grants outstanding, memory grants pending? I will talk about stolen server memory a bit later. This is much more complicated. I don't touch stolen server memory for today. I will just touch these four counters. Memory grants outstanding, memory grants pending, target server memory, and total server memory. What's our take on this? These counters are very important when you are working with memory pressure or memory related issues. Okay, so anyone knows what is target and what is total?
Total is like the memory is signed for SQL Server,
Okay, what is target?
and the target is like it's if any query is running behind that. So how much memory it's going to be used for that execution? That is the target one.
Okay, any other answers?
Yeah, target is a max memory setting which we allocated to SQL Server. The
Okay,
total is how much right now SQL has been utilized.
okay. So people are saying like, okay, so I'll say target is whatever what we assign for max server memory, and total is what SQL is consuming at the moment. Okay, that is simple terms. SQL, what SQL is consuming currently. What SQL is consuming currently. So looking at the below picture, consuming currently. So total server memory means what SQL is consuming currently, right? So this is in KBs. So if I round it off, it comes somewhere around 9.5 GB. Okay, total server memory is 9.5 and target is somewhere around 10 GB, I can say. So the first point here is if I go to, I already explained this, but I'm showing it again. I'm sorting it based on memory. Okay. So in the descending order, currently I'm not able to see SQL Server. I mean, this is a SQL Server, but it is showing me as 123 MB. So I already explained the reason for this, but I'm just letting you know again. We should not be trusting Task Manager whenever we are dealing with memory issues. Don't go with Task Manager. Okay, Task Manager will not display you the correct usage. Okay, when it will not display you the correct usage, it will not display you the correct usage provided if you enable lock pages in memory setting. In my case, I did that. So that is the reason Task Manager will not show you up the actual usage of SQL Server. Okay, so you can see the large log pages, right? So this value 9510322 and this value are one at the same, almost. I mean, maybe here and there some values might be different, some KBs, but if you see them, see this is the stuff. So first point, what you have to keep in your minds is when lock pages in memory setting is enabled. Okay, when lock pages setting is enabled, we should not be trusting Task Manager. That is the first point that you have to keep in your minds. Very, very important thing because you might be wondering like, okay, I have 10 GB of consumption or 9 GB of consumption in the Puffman counter or in the DMVs, but in reality, in the Task Manager, it is just showing me 120 MB. So where is the leftover memory? So that is the thing. So this is the thing that you have to remember. We should not be trusting Task Manager when we have AW enabled for on our servers. So how will we enable this setting? Okay, I'll just quickly open that up, but I'll show you later. So if there is something called as group policies, inside group policies, there is something called as lock pages in memory. Once that setting is enabled, uh, then lock pages in memory will be there by default. Any questions? Very, very simple topic, but if you have any questions, let me know. Just question yourself when we should not be trusting a task manager. The answer is when we have lock pages in memory setting enabled, we should not be trusting lock pages in memory. Sorry, task manager. So this is what I'm talking about. Lock pages in memory. When this setting is enabled, we should not be trusting um, uh, what is it? Task manager. So if you see now, my SQL server is running with local system, right? My SQL server is running with local system. And if you see here in under the lock pages in memory, uh, uh, there is no account. Any service account is being placed here. Okay, but in real time, your accounts will be with some domain account, something like a domain name slash service account. So you have to add that here under the log pages in memory. So this requires restart also. Just keep that in mind. Okay, can I move on? Any questions?
Yes. So I have a question here. Like,
Yeah.
I think it's a very um, the log page memory. Basically, what is the function? What it's giving the well performance, or what is that? Like, why we
So
are.
yeah, it will be a huge debate even if you ask Microsoft employees. So if there are 5 or 6 employees, two of them will say log pages should be there, and four of them will say we don't need log pages. So it's a debatable topic. But if you ask me, and if you have multiple instances running on your machine, or if you have multiple components running on your machine, then setting up log pages in memory will be helpful for SQL Server. That will be my answer.
Okay, let's say example like I have a two node cluster. So in
Yeah.
that, what will be the best option
So
for running?
when you have two node, if you have only one SQL instance, then you don't need to worry about log pages in memory. You got my point. There is just one instance, right? It will switch from
Yeah.
node 1 to node 2. So that means it's nothing but one SQL Server instance floating between two servers. In that case, I don't mind. And if you are setting log pages in memory, you have to ensure max memory is also there. So we'll talk about log pages in memory extensively, but I'm just giving you a glance. So whenever we use log pages in memory, okay, internally, internally, this is what you have to understand. Internally, it uses different algorithm. Okay, so there is something called as virtual alloc and physical AWE. Those are the algorithms. I don't want to go up to that level during this session, but you will see that. So there is something called as virtual alloc, and there is something called as physical underscore something. There is some algorithm. So I will touch those algorithms. As I said, there are some theoretical stuff that I need to pass on. So I'll touch there. The only
Okay,
important thing right now is don't trust task manager if log pages in memory is enabled. As simple as that. So
understood.
if you wanted to see the real usage, you have to go with resource monitor. Here it will show you the real picture of SQL Server, where SQL Server, let me go to memory. Can you see this? Now you can see 10 GB. I mean, 9 point something. It's okay. I mean, don't, go with the closest thing. Just understand the basics. So it is something like 9.7 or 9.8.
So
So here, yeah,
we can trust here in
exactly. In
monitor,
resource,
performon or in a DMVs, right?
yeah, resource monitor, you can test, not task manager.
Understand. Yes.
So that is the first thing. So when we should not be trusting when lock pages in memory setting is enabled. As simple as that. Okay.
Great.
So let's move on. I'm going to restart my uh, instance before I perform restart. So these are the values what I got. Almost same. Target and total server memory is same. Okay. So let's wait for it. I'll just keep this. Okay. Now I'm going to restart and see what happens with respect to SQL Server. I mean, I'm talking about max server memory. And 1 second, let's wait. By 4:15, it gets very dark here.
Might be your feeling because you came back from India, na? So that is also a reason.
Yeah, I mean, it really turns dark by 4:30.
Okay. How was your trip, India trip?
Yeah, it was busy. Like, I didn't get time to do many things. Just carried out the basic stuff. Just wait. In the meanwhile, okay, it will get started. Just it is taking. Hope it will not disturb our class.
It's taking long time, I think.
Yeah, something
Somewhere.
fishy. Let's see what is happening. Yeah, this is the problem with memory. When you touch memory, you have to wait. We have to have our patience. It will take some time to respond. Even the event viewer is not responding. Let's wait. Okay, I will do one thing. In case if it doesn't respond, I'll just keep them aside and I will restart the mission. Let's check this. Still not responding. Doing few things here. Just a second, guys. If it doesn't respond, we'll do restart of the mission itself.
We can try it shutdown no wait.
Yeah, we'll do that. I think it will not allow me to do that command if I'm not wrong. Let's see. Let's open services.msc. It's still running. Okay, let's connect now. Let's see. Okay, it went now. So let's start the service. Both are same, guys. I mean, don't get confused that I'm using command line. It's better to do command line sometimes because it responds fastly. So it is back again. See, this one is not responding. Means some issue with configuration manager, not with SQL Server. Okay, we just restarted it. Let's check the values here. No, it didn't restart properly. I can say that. Or yeah, okay. Let me check just before. Just a second. I'll just check the restart date just to ensure that it has happened properly. SysDM. What is the EMV? SysDM.
Server service.
Yeah, server services will give. There is dedicated DM, right? OS sysinfo. What is that? OS sysinfo something. Yeah. Here there is one column by name SQL Server start time. That is the reason I'm just picking up. So yeah, it went fine. 16:20 means just 2 minutes back it got restarted. Fine. So now if you see this values, so this is 1983256 means this is 1.9, 1.9. Okay, total server memory is 1.9. Whereas target server memory is 970. So it's somewhere like 9.5. Why total server memory has come down drastically? And even if you see here, previously it was 15 GB. Now SQL Server is just 7.8 GB. As I said, we should not be trusting Task Manager. So I'll close this off and I will see the SQL Server usage. Can you see this? It's just 2 GB, not 9 GB or 10 GB, what it has shown before.
Earlier it was 9 GB approximate, yeah.
Guys, are you getting? I will slow down here and I will ensure we are on the right page. So my question is, why SQL Server is just showing up 2 GB instead of 9 GB or 10 GB, what it was shown before?
It will clear the cache buffer.
We started the sorry. Yes.
Since we restarted the instance, all the usage of buffer pool and cache, everything, procedure cache, buffer cache, everything will be wiped out and it is starting slowly. So when it is starting slowly, okay, I will just add uh, max server memory and min server memory also. It's not required. These 5 counters are good enough. So current usage, as I said, this is the statement what I passed. Total is nothing but what SQL is consuming currently. Okay, since we just restarted the instance, it is just showing up as 1.9 GB. I'll just say 1.9 GB just to ease our needs. I cannot do that 1024 and 1024. I'll just say as 1.9 GB, and target server memory is nothing but whatever the max server memory what I assigned. Okay, so that is the difference, guys. Target server memory and total server memory. So what is total server memory? Total server memory is nothing but what SQL is consuming currently, whereas target server memory is nothing but what is the max server memory what you have set. Okay, just understand the terms. We will see when to use this target server memory and when we can consider as memory pressure. Those things I will explain it later, but I'm just explaining you the basics. The first basic what we learned is when log pages memory in setting is enabled, we should not be trusting task manager. That is first point. Second point, what is target server memory and what is total server memory? Target server memory is our max server memory, and total server memory is nothing but what SQL is consuming currently. So these are the two things what we learned till now. Any questions with these 2 points? Just 2 points. Okay, let's move on. And now let's try to understand something more with respect to these 2 counters, memory grants outstanding and memory grants pending. So I am just very keen with these 5 counters because most of our issues can be, we can deal with our memory issues if we understand these 5 important counters. So that is the reason I'm just picking up these 5 counters. We will see other counters in upcoming classes. But if someone asks you to go and work with memory issues, so these are the 5 counters usually what I make use of when I'm dealing with performance issues, especially with memory. Okay, let's start. And I'm just running a query, just one query. Okay, so I'm just using Stack Overflow again. So some join condition and blah, blah, blah. So this is the estimated execution plan. This is how it looks. Okay, so I'm running this query. Okay, so it just got started. And now understand the usage of flux, memory flux, and understand the usage of something else. Okay, I'll talk about that something. Can you see this SQL buffer pool? SQL buffer pool. What is SQL buffer pool and what is SQL reservations? These are the 2 important things that you have to watch out for when you are dealing with memory issues. Just like these counters. Where are those counters? Where is that counter? Did I remove something? I had that query, right? Okay.
You can control it. It will.
Yeah. Okay, I removed. Sorry. We'll just understand output of these 3. So there is something called as memory flux. We will go through that memory flux. Don't worry. I'm just giving you an introduction. For the moment, it's all about just basics. Okay. When you see memory flux, the top consuming memory flux, okay, usually it should be buffer pool, SQL buffer pool. What does SQL buffer pool holds? What does buffer pool contains?
Data pages and index pages.
Yeah. So it contains our pages of our databases, right? So that is what it contains. So currently it is increasing because it is fetching the pages from memory. Okay. So when I ran this query, the related host table and votes table and users table, those tables are not there in my buffer cache since we just restarted the instance. Okay. So that is the reason we are seeing buffer pool getting increased slowly. And if I run these counters also, can you see now target server memory and total server memory are one at the same. At the beginning, when I just restarted the instance, it was just 1.9 GB, but now both of them got matched up. Target server memory and total server memory. And again, it got stuck. Just a second. Why it got disconnected all of a sudden? So I don't know why I got this error. Is it because of this one? Okay, it is now back. SQL server stopped. SQL server got stopped. I don't know why it got stopped. Let's check the logs. When I'm dealing with something important, we will see some weird behavior. It's okay. I hope it is back online. Yeah. Since it got restarted, now if you see again, definitely will notice target and total will be in different states, and the total surround memory is back to 1.9 GB. Okay. Since there are no queries that are happening right now, total surround memory is far less than the target surround memory. So once we start running our queries, you will see the rampage. Means it will start utilizing that. So now you will see it's growing up. At the same time, our buffer pool also will start growing up. Buffer pool is just 1.9 GB. Now you will see it's getting increased slowly. Okay. So now are you getting the concepts? So how total server memory is catching up with target? 6.3, 6.7. And even if you see the buffer pool is getting increased now, 5.9, 6.2. So it is slowly, gradually, it is getting increased. So it will try to catch up the target server memory. And once we reach that values, both will be almost same. So when you see target server memory and total server memory as same, it means ideally we don't have any memory pressure in general. Okay. When I'm passing the statement again, when total server memory and target server memories, when both are same, it means we don't have any memory pressure. Currently, it is 9.7 GB, what is being utilized from SQL Server. And if you see here, buffer pool rampage, it went up to 6.8 or 7, something somewhere close to 7. So it will get fluctuated. So there will be fluctuation. So you just need to understand what is buffer pool. Buffer pool contains data pages and index pages of our databases. Okay, so this query is currently running. And if I see now, whether it is SP who is active, I'll go with SP who is active because most of you are familiar with SP who is active. So, sorry, SP who is active. Okay, I have just one query that is running, and it is waiting for page latch shared. Okay, so that is the wait type, what it is showing up, page latch share. So I told you many times, instead of SP who is active, I tend to go with SP blitz who. So now you will get to know why I'm saying SP blitz who. You will see this practically. So what is this SP blitz who? SP blitz who is nothing but this is the script from Brentozer. So if you are allowed to run Brentozer scripts, then I definitely recommend SP blitz who on top of SP who is active. I will tell you why. Both are same. Both will give you the current active running sessions. But I prefer SP Blitzu for one reason. Just I'll talk about that one reason now. Okay. So I will run both of them together. Session filtered. Okay. Yeah, I got the output right. Can you see now? SP who is active and SP Blitzu. When we see SP who is active, okay, when we go to wait info, currently there is no wait info associated with this. Even the same goes here. Where is the wait info? Wait info is here. Okay. I'll run it again just for one more time. Can you see this one, top session wait types, which is not there with SP who is active? We just have wait info. That's it. We don't have anything else here. What is the difference between this one and this one is nothing but wait info will show you what is the current wait type. Current wait type. Only when I'm executing this, the query is running from from this session, right? So currently it is not waiting on anything as per SP who is active. And this guy will help you to get all the top session wait types. Means this query is running from past 3 minutes 50 seconds, right? 3 minutes 52 seconds. So it will give you on what wait type it waited for this much time. So this one is like 4418 milliseconds. And if you see here, 171,559 milliseconds means most of the time it is waiting for parallelism. So if you see here, parallelism is the main reason. So what is the previous wait type associated with that query will not, it is not there with SP who is active, and you can get that information with the help of SP Bitsu, which is the use case, which that is the reason I said it got upper hand purely because I can get the previous wait stats associated with that query, which is not there with SP who is active. SP who is active will show you only the current wait, what it is waiting on. But Blitzwho will give you current wait as well as the top session waits associated with that query. So mostly it is happening because of parallelism and because of it is waiting for the pages to be read from disk, page IO latch underscore shared. So that is the reason. So now I know this query is having some issues. So it is prone to parallelism. I mean, I'm having issues with parallelism, and also I'm having issues with page IO latch. Means there are no sufficient indexes. I don't, if we don't have correct indexes, it has to read the pages from the disk to get the data. Okay. So that information we can find out with the help of Blitzwho instead of SP who is active. So if I run this again, SP who is active will give you only the current wait stats. Currently, it is not waiting on anything. It is running, but here it will give you the proper picture. So if I sum this up, it will give you the exact time. Like it is running from 5 minutes 32 seconds, right? You can get that information if I sum this up totally. Like if I sum this up, complete wait stats, it will give you the same time. So that is the advantage of using Blitzwho over SP who is active. Any questions here? I will slow down myself if I are not able to understand, because these things are not that easy to understand. So that is the reason I have to be little slow. Come with your doubts. I will handle them. If no questions, we'll just proceed.
What it means BP short?
It is using sorting. Okay, so if I just took this, if I take this query and just go to new window, sorry, control and right, new query. Can you see the estimated execution plan? So we have
Yeah.
sort here. Okay,
Okay.
so BP sort is also kind of wait, where it is waiting for this sort operation to get finished. So that is the reason you are seeing that BP sort here. I have to minimize this because many people told me that they are having issues with this display. Okay. So now this query is executing from past 6 minutes 53. And you know what? This query runs for almost 30 minutes or more, maybe more than that. So that is the problem with this query. Okay. Now just imagine how you will get memory issues. Before I introduce that memory issues, just take a note of this picture, this output. So currently it is 9.8 GB. What total server memory is showing up, and the target server memory is 10 point something. Okay, so I'll run this again. Okay, this is what we got. Okay, now what I will do is, before I do, I just wanted to explain one more thing. How much memory is the current query is consuming? How can you say that this query is consuming this amount of memory? So that is the common doubt what you have. So how much memory is being consumed, or memory grant? We should say memory grant. Okay, how much memory grants is being consumed by this query? Session ID 73. So you can get it from EXEC memory grants. Okay, very simple DMB. If you run EXEC memory grants with the EXEC text, you will get the text means the query, what that is running currently, and the session ID, and how much memory is being requested and how much memory is granted. So if you see here, it is requesting for 1.8 GB. Can you see this? 1833. So it is nothing but 1.8 GB. So that query is taking 1.8 GB of our RAM. Okay. Now I will go and introduce some stress or memory issues. Oh, there are 5 charts here. How do we know it is log pages in memory? I think I explained this. It is type of environment matters for log pages in memory. So I will take this question. Stolen memory, I will explain it later. Where is the previous one in the top session? Wait, stats. I didn't get this counter. How memory usage is affected when you do DBCC drop buffers? Okay, we'll take these questions later.
Uh,
Yeah.
Vamshi, what I was asking, like in SP underscore blitz, like you said, right? It will show
Yeah.
the previous memory also, memory weight also. So I was addressing that one.
Okay, okay.
Okay.
Thank you. Just
Right.
a second. Where was I? Yeah, okay. I need to introduce the issues, right? Okay. I'm using query stress and I have O stress as well. So to mimic the real world, we have to make use of these tools because I cannot create that load, right? What you see on your real-time systems, I cannot generate that. So I have to use some tools. So I'm using query stress and O stress. You can use any one of them, but uh, if you want GUI, you have to use query stress. If you want command line, you can go with O stress. I'm just taking the same query. Okay, just imagine this query is being fired from multiple missions, just like in real time. So it's the database. Okay. Okay. And now just imagine I'm firing this query for 5 iterations with 5 threads. Means I will be having 5 connections from 5 different servers. Let's go with 7 for a moment and let's run this. Okay, I'm just trying to mimic the real world. Okay. So now I'm running something from an application. Okay. Now if I run uh, this command, okay. So now for few queries, we are seeing granted memory as null. Okay. Just focus on this output. For few queries, you are seeing it is requesting 1.7 or 1 GB of RAM. But for few queries, SQL Server didn't grant the memory. It is just showing up as null. So what is null? And now you'll be able to understand what is memory grants pending and memory grants outstanding. Okay. So now I'll run both of them together. Then you will get to know. So how many values are there? Counter value is 3 for memory grants outstanding and memory grants pending as 5. Can you see how many nulls do I have here? 1,
5.
2, 3, 4, 5. Means memory grants pending. Memory grants pending is nothing but I got this around. I'll just close this for a moment. Memory grants pending is nothing but it is waiting for SQL Server to get the memory. Okay, the query is waiting for SQL Server to grant some memory for it. So that is nothing but memory grants pending. So you're seeing nulls. All these nulls are nothing but memory grants pending. And memory grants outstanding means SQL Server has granted the memory and it is still working on it. It is still working. Means the query is making use of my memory and it is still working. So it is requested 1.7 GB of RAM here and 1.8 here and 1.7 again. So 3 of them are making use of our memory and 5 of them is waiting. SQL Server has not granted uh, uh, memory for these queries. And now I told you this session is about resource semaphore, right? So now if I come over here and run SP who is active or blitz to anything. So if I run SP who is active now, just wait for it. Since I introduced this memory pressure, so everything will be slow. Okay. So 3 of them are waiting on page avalanche. So these 3 queries are related to memory grants outstanding. Okay. Memory grants outstanding. And 5 of them are waiting for memory. So that is the reason you are seeing these wait types as resource semaphore. Okay. Resource semaphore waits. So whenever you see resource semaphore waits, it means your query is requesting for large memory grants. And if I have memory, I will be able to give it for you. If I don't have memory, then you have to wait. So that is what it is happening. So I will give you one more real-time query that you can make use of. It will give you the entire picture. So that is the best query that is out there on the internet. So that is the reason even I saved it as memory usage best query. So if I run this query, because it gives you entire picture. So just give me a second. I will just copy paste here. So this gives you how many queries are waiting and how much memory has been granted. If you see, most of them are waiting on resource semaphore. resource semaphore, right? So that is the thing. Whenever you see resource semaphore waits means, and along with resource semaphore, if you see your memory grants outstanding and memory grants pending not zero, not as zero, it means you have memory pressure with respect to SQL Server. Means SQL Server is not able to grant memory, whatever the queries are requesting. Okay. Are you getting now? This is the most important thing. I will slow here again. Let's understand this slowly.
See, can you go on the task manager or like,
Yeah,
not
I will go to task manager. Even now, task manager will not show you the real usage. So it's of no use when you have log pages in memory. So let's wait for it. So now current memory is 96%. Even the CPU is 100%. Can you see this? SQL Server is using 96% of CPU and 96% of memory. Real-time issue. What you will see and real-time also one at the same. And if you see now, even now it is showing just as 121 MB.
how much the memory, like CPU is showing 100% and memory was
Memory is just showing as 121 MB. As I told you, we should not be trusting task manager. We should trust only resource monitor. So currently SQL Server using 10 GB of RAM, but in task manager it's showing 120 MB. So that is the problem. Don't ever trust uh, task manager if you have issues with, if you have log pages in memory setting enabled.
Yeah, Vamsi, it is memory is called buffer memory, right?
See, buffer memory, procedure cache memory, these are all different terms. Okay. So just call it as memory for the moment. So this is the SQL Server.exe process, whatever that is consuming right now. So it is consuming 10 GB of RAM out of 16 GB what I have on my server.
Yeah, Vamsi, it is memory grant, and you said one more thing, right?
Yeah, we will
What if the
understand.
pages are already pages are there in the buffer?
Yeah.
The queries, why can't the queries use the same pages for different queries, right? Will they use that, right?
Yeah, they are using. Okay, so let's understand this slowly. Let's understand, because I told you this is not such an easy topic to explain. Let's understanding this very slowly. Okay, I have 3 memory grants outstanding and 5 memory grants pending. So did you understand this topic first? What is memory grants outstanding and what is memory grants pending?
Memory grant outstanding is memory allocated to those query, and pending is like the query is not able to fetch the data from the buffer cache.
No, I will just ease that out. Memory grants pending means SQL Server has requested memory for its query execution, but SQL has not granted the memory. Okay, there is no memory for it. There is no space or memory for it to allocate. Okay, since it is not able to allocate, that is the reason you will see memory grant as null here. Okay, you are seeing nulls. Whenever you see nulls, that is nothing but your memory grant spending exact value. Okay, memory grant spending is nothing but, I will just simplify this. You requested memory means queries, not when I say you, it is nothing but our queries. Queries requested memory, and SQL Server is not in a position to grant them. SQL Server is not in a position to grant them. So when it is not in a position to grant them, you will see the wait types as resource semaphore. Understand this very slowly. Try to understand this because this is very important. So 5 of my queries are waiting for memory, but SQL Server has not granted memory for them. For other 3, they are still executing and they have the memory. Getting or not?
Is there any locks on that?
No, there is no lock, nothing. So I will explain resource semaphore very much deeper in the upcoming classes. So there is something called as small reservations and large reservations and all those topics. But today it's just the small picture. You will get the real big picture in the upcoming classes. But try to understand these things. Are you getting? Yeah.
Actually, just a question. Can you please repeat? You mean to say, in case if it shows as null, it has already allocated the memory.
Yes.
It does it.
Yes, it has
Okay.
allocated the memory. So if you see here, this is SP who is active output. Okay. So here we will not be able to see the memory usage with SP who is active. So this is a DMV. Okay. I mixed up, not me. It is available on the internet. So I just took this DMV. So it goes and it fetches all the details. So let me run this DMV. And it's a lengthy DMV. So now if you see, most of them are waiting for resource semaphore. Okay. And here, if I scroll it down, then you will be able to see, I'm running this from SQL query stress, right? I told you this is from SQL query stress that I'm generating. So you are seeing the program name, host name, mission, everything, client, everything. So now if I scroll it to my right, this is what it has requested. 1.7, 1.7, 1.8, all this stuff. But granted memory is null, means it has not granted any memory for these queries. It has not granted because there is no memory for me to grant you that. So you may have a question. So let's stop here for a moment. They are still executing. So now, if I go to this window and if I run this value again, so it is just showing up 10 GB, right? Approximately 10 GB. So why it is not going beyond 10 GB? That is first point. Second thing, if I go to memory clucks, okay, so now my buffer pool is getting shrinked and this component SQL reservations is going up. Okay, SQL reservations is almost 5.2 GB and buffer pool is 6.1 GB only. So what is this SQL reservation and from where it is getting the memory? So what is happening? How to understand
So
this reservation?
yeah, reservations is intermediate result set like a sorts and all this. So we are running multiple queries since here, and it requires more memory to do sorts for each query separately.
Okay.
So that is why it is occupying more than buffer full. And for buffer full, it may happen page avalanche definitely, but because it won't fit all the pages here.
So if I
Since we
see
capped
the,
max memory also, right?
yeah. So if I see the memory, I mean, I'm just going with SP who is active because that is the only one that is available for every, uh, in every environment. Currently, those three queries are running and it's not waiting on anything. Okay. And these five queries are waiting for my resource semaphore. I mean, there is no memory allocated. So what is this SQL reservation and from where I will get this SQL reservation? We'll talk about SQL reservations for a second. So buffer pool, I hope we are clear. Buffer pool is nothing but your database pages and indexes. Okay, database pages and indexes. Usually it has to be high. It has to be high. And SQL reservations will be, it has to be low. But in our case, it's almost equivalent to buffer pool. So something is happening. And because of that reason, I'm seeing SQL reservations catching up with buffer pool. And there is one more um, tool that you can make use of, but I don't think, I mean, I should not be encouraging this because most of you will be working on banking domains or something like that. So this is one more script from Eric Darling. So I do follow Brent Ozer and Eric Darling a lot. To be very frank, I follow Eric Darling a lot than even more than Brent Ozer. So he has developed something called as SP pressure detector. So when you run this, it gives you even more right picture, especially with respect to memory. Okay, just wait for the output. I'm not saying that you have to run SP pressure detector and all. I'm just letting you know how SP pressure detector can help you. And if you're allowed to run, definitely make use of SP pressure detector. It is very, very handy. Can you see this? It is giving the same information. 5.6 like memory clucks, whatever what I'm using. So you can get the same thing from memory clucks also. So that is the reason I'm just showing up memory clucks first because this DMB can be, you can make use of that DMB anywhere. But if you're having issues and you are not allowed to run this SP pressure detector, you have to use DMBs. If you're allowed to run SP pressure detector, this is the easiest way to find out if there are any problems. So this is the buffer pool memory and it is 5.6 GB and memory clerk SQL reservations is 5.16. He's getting the same info from that DME only. Okay. So now the point here is why SQL Server is able to grant memory only for three queries. Why not for other queries? That is the first thing, right? Can you see here? Grantee count is 3 and waiter count is 5. Again, you can get this information from um, this Puffman counters. We have seen memory grants outstanding as 3 and memory grants pending as 5. So he's pulling all the DMBs and he's giving us this output. And even if you see the log pages in memory, that is the model what we are using here. So that is the reason you are seeing log pages also. And I told you there is something called as resource semaphore ID 0 and 1. We'll talk about that later. For the moment, let's try to understand basics only. My question is why we are not able to grant anything more than three queries. So we are just going with only SQL Server has granted only for three queries. but not for other queries. 5 of the queries are still waiting. Why? What's our take on that? Why is not able to grant? Anyone knows this?
I think it's not able to grant because SQL Server reach the maximum server memory.
Okay, let's go to that max server memory once. Even I'm just clicking on properties and it's taking time because we have memory pressure right now. So it will be very slow in responding. So currently I've set this up to 12.5, means if I round it off by 1024, something like 12 GB. So 12 GB is what what I have given to SQL Server, and it is using how much? 10 something, right? Or 10 GB. So it is not going up to 12 GB. It's just going with 10 GB only. It's going up to 10 GB and it is sitting there. That is first thing, which I need to clarify. Okay. It's going up to 10 GB and it's not going beyond that. That is first thing. And I have to talk about this stolen server memory. I will talk about that. And why I'm not able to go beyond uh, beyond 3. So I got only, SQL Server is allowing me to execute that query only from 3 different sessions. But anything after that, it is putting up in wait state. Resource semaphore wait state is nothing but SQL is saying, okay, boss, I don't have memory. You have to wait. So that is the reason we are waiting currently for SQL Server for its memory allocation for that query. Yeah.
Vamshi, I'm just guessing it. It might be the exclusive lock which is happened on that tree, which is not allowing others to give the memory, if I'm not wrong.
Exclusive lock in terms of, you mean to say locking, something like that?
Exclusive locked will not allow the other queries to run until and unless it won't uh, complete the process, right?
We don't have blocking here. So if I have blocking, so if you see here, do you see any blocking?
No.
No, I know.
Block. Okay.
So I'm just letting you know.
Okay.
Exclusive locks and all, usually if share locks and exclusive lock from that terminology, if I talk from that terminology, currently we don't have any blocking. Okay, right? Currently there is no blocking.
Okay.
And what you are saying is, okay, I will explain the reason. I'll just give you a glance. Okay, we'll talk about that in depth in the upcoming classes. There is something called as, I didn't turn on the resource governor, guys. I never made use of resource governor for your information. I didn't work on it also, but by default, resource governor comes into picture. Okay, and it does something behind the scenes. I am not doing this on every system. You will see this. Okay, on every system you will see this. Can you see this workload groups for resource pool default? So these are defaults. I have not touched this at all. So there is no relation. And see, even if you see here, resource governor is not being enabled at all. Okay, so just if you install SQL Server, these are all the defaults what you see. Can you see something here? Per group, groups for resource pool default. And what is the memory grant? It is showing up memory grant percentage 25, right? This is about CPU, default internal pool. Okay. So if you see here for memory grant, it is showing up something like 25. And this is external resource pool. I don't have anything. Currently, we are going with just default and it is showing up as 25%. Just keep that in our minds. Okay. We'll talk about that later. So that is the reason. Actually, the answer is here. Okay, these are all defaults. Again, I'm saying I didn't touch resource governor. Even on your missions, you will see the same thing. Unless and until if you have configured resource governor, these settings will be very, very similar on all our systems. Again, I'm saying I didn't touch this. These are all the defaults. Unless you worked on it, it is one and the same. 25% is what it is showing up. So out of, okay, so these are the questions that I will explain in my upcoming class. For the moment, just hold your now. I don't want to go beyond this. So what are the questions what we have? Why SQL Server is not able to take that 12 GB? That is the first thing, right? So we got 12 GB of max server memory, but it's not able to go up to 12 GB. It's just going up to 10 GB and it is sticking there. It's not going beyond this. That is first thing. Second thing, stolen server memory. I need to explain what is stolen server memory. And third thing, you need to understand what is SQL query reservation? What is this SQL query reservation? Why it is going up to 5288? And why my buffer pool has come down? Like it was previously showing 8 GB or something. Now it is just 6 GB. And this was just 1.9 something. Now it went up to 5 point something. This value is very simple. So this value is nothing but if you just multiply these three, granted memory, where we got the memory. So 1726, 1833, and 1726. If I sum this up, this will be same. Whatever SQL query reservations is showing up. So SQL query reservations is nothing but whatever the memory that SQL has allocated for those queries will fall under SQL reservations. So the point here is when SQL reservations is close up to our buffer pool, then definitely you will see resource semaphore rates, and we have memory pressure here. Okay, that is the point here. So we will talk about memory concepts in the upcoming classes. I just wanted to give a glance like how my classes looks like. So is it not matching up with real time? Like you are seeing this resource semaphore rates and we don't know how to handle them, right? See this query. This query is still executing 29 minutes, 15 seconds, 30 seconds, like 29 minutes, 50 seconds. For just one query, if it is taking this much time, just imagine. Of course, we do have load here. We do have load. Okay, I'm stopping this load. Any questions before I present you the solution? Like how to work on resource semaphore rates?
So, Bumps, actually, what I'm thinking like a SQL query trace is actually external tool actually occupying the worker process with some set of the load count which you have given here, the iterations values.
Mhm.
And that's the reason he's just going with that dedicated
Okay.
memory first.
So that is your question, right? So let's start the. Sorry, let's stop these. Can you see the CPU usage also? It's constantly 100. So stay there.
Mm.
Okay. So let me stop this SQL query stress. Did I close it? SQL queries. Where did it go? I think it's gone, right? Let's check that. Yeah, it's gone now. Okay. So now I'll clear your question. Just give me a second. Now if I run this, okay, memory grants outstanding is 1 because only this session is running and all others are gone. So pending is 0. And now if I run our memory clocks, you will see buffer pool is 5.3 now. It will not grow up. I mean, it will not show you that 8 GB or 9 GB instantly. You have to run queries so that the buffer pool comes into picture. Okay, so currently reservations has come down because we don't have any queries waiting. So reservations has come down. That is the first thing that you have to understand. Second thing is buffer pool will not show you, it will not go up instantly up to 10 GB. It will grow provided if we start running queries. Okay, that is second thing. And now instead of query stress, you said query stress is the problem, and because of some other stuff, it is showing up something like that. So I will take the same query. Okay, and I'm running this from different sessions. So this is third session. Okay, so I'm going up to 3 sessions. I don't want this one. I'll close this off. This one. Okay, I'll make use of this one. I'll share this query. So up to three sessions. Okay, 1, 2, 3, 73, 61, and 78. All three of them, they got the what is that? They got the memory and they are running now. So now I'm taking a new session. Okay, fourth session, and I'm running it. Okay, now check the output. Now see resource semaphore. It's not just SQL query stress. Even if I open SSMS, SQL Server can allow you to run only 3 queries. The fourth new query window, it will not work. It will stop. It will go for resource semaphore. Even if I go with some other new window, and if I run this up, okay, then you will see the same wait type for the new session also, 69, I think. Or even if you use SP who is active also, you will get the same information. You see, resource semaphore. Now you are seeing resource semaphore waits. So that means SQL Server is giving you only like close to up to 5.4 GB of RAM for your queries out of 16 GB what I have on the server. Okay. SQL Server is just giving you 5.4 GB of RAM. So I will explain these reasons tomorrow, maybe, or I would like to take tomorrow, if not the next session. Just keep a note of it. So I have 16 GB of RAM. That is the total server on the memory. And I've given 12 GB to max server. So 12 GB is the max server. Okay. And SQL is allowing to run only 3 queries. And that is coming up closely to 5.4 GB, I can say 5.4 to 5.6 or something like that. So why we are not able to go anything beyond that? Okay, that is the question. So even if I show up that window, where is that? This one. Now you will see again memory grants pending coming into picture and outstanding coming into picture. Just wait for it. Memory grants will be 3 and pending will be 2 because 2 of the queries are waiting on resource semaphore waits. So whenever you see resource semaphore waits, you will see memory grants pending automatically. So this is the correlation. Okay, outstanding means it has given the memory but still not able to complete. And now total server memory has come down because SQL is ramping up now. I mean, three queries are running now, right? So if I run some other query, then you will see total server memory and target server memory are same, and it fluctuates. I cannot generate exactly to mimic that of real time, but I'm trying to give my best. Okay, now let's stop this. And now, as a DBA, what should I do now? That is the problem, right? Right now, I have memory pressure, and that memory pressure is happening because of this query. And they're asking me to work on this query. So what should I do as a DBA? Let's stop this and let's focus on query tuning. I mean, how to solve that problem.
One question.
Yeah.
So memory grants pending is a negative parameter, whereas memory grants outstanding is not necessarily a negative counter. Can we say that?
Exactly. You got it right. Memory grants pending is a kind of negative because I am not able to get the memory from SQL Server. Memory grants outstanding means, yeah, we got the memory, but unfortunately, we are not able to finish that off. That's true. Yeah. So I'm stopping. No. Okay. So now we are back. This query from this beginning of the session, I'm running this query and it is still running 36 minutes. Just imagine. So now as a DBA, what should I do to reduce the memory usage for this query? And also, even now, the CPU is 100%. So we have problem with memory and as well as CPU. You can trust Task Manager with respect to CPU, but not with respect to memory. When lock pages in memory setting is there.
Yeah. Here, this memory issue is, triggering that CPU to be 100%, right?
So I'm not saying memory is driving that CPU here. Both are different. Currently, we have 100% here. Okay, both are different. It's not at all related to memory. To be very frank, it's not related to memory. I just have one query, and that one query is running from 37 minutes, and it is taking up CPU. Okay, now I will be going a bit deeper. Are you able to understand till this point? Because I'm worried because these concepts are like high level. It's not that easy for junior DBS to grab them.
Well, yes. Once this is clear now, whatever you explained, that is clear. I'm a bit confused about the CPU.
CPU part you will get to know shortly. I will explain why CPU is going crazily. Up to this point, any questions? Yeah.
Just now, like you were running the same query simultaneously, you
No,
ran from a different sessions,
I'm
right?
I'm
Just
not
before.
running. Yeah, just before I ran, but currently we have only one session. Only one session.
Yeah, just a question. So
Yeah.
just before you were running same query from different sessions, and you said SQL has allocated memory only to the 3.
Only 3. Yes.
So
That's true.
in the real time also is it the same?
Same thing. Same thing. So you will get to know why and how it works. Okay. So in real time also these concepts are absolutely same. There will not be any changes. Now we have only one query that is running. Okay. So that query is still running from past 38 minutes or so. And it is eating up 100% of CPU, and still we are not able to complete that. And now, why the question is why CPU is 100%? Is it because of memory? That was the question what we got. Is it because of memory that causing CPU to go high as well? So that is not the case. Okay. So why I'm saying that, because now that is where SP Blitz who will be super handy. If I just go with SQL SP who is active, see currently weight type is null. I don't have any other information. But now if I go up with SP Blitz who, because I know the previous weight types, okay, because I know the previous weights types, I can say what is the problem. So let me copy this for a second. So these are the weight types. So what's your thought on this? These two, these three, not two, these three.
CX packet, parallelism.
CX consumer, CX packet, CX sync port, everything is related to parallelism. Okay. So this query is parallel prone, means this query will get executed parallelly. And if I go to my settings currently, I have 4 CPUs, I believe. Just wait for it. Yeah, I'm pretty sure it's 4 CPUs. 4 CPUs and 16 GB RAM. Yeah, 4 CPUs. Okay, and just one NUMA node. 4 CPUs. And I didn't touch max top and all. These are all defaults. So cost threshold for parallelism is 5, which is again the default. And max degree of parallelism is 0. So that is the reason currently this query is having problems, not because of memory, because of the parallelism settings what we got. Okay, the parallelism settings what we got. So now if I stop this query, so currently you can see this, right? 100% CPU. I just have one query running on the machine, nothing else. So previously you may be expecting because of query stress what I have delivered, might be because of that I got that 100% CPU, but that is not the case. So even with one query, I just got one query executing right now in front of my system. But even that one query is causing issues purely because of parallelism. It is nothing related to memory. Okay. So why I'm saying confidently, because if I stop this, okay, I'm stopping this query because it's of 40 minutes and still it's not able to complete. And now if I add this max stop hint as 1, okay, and if I now exit, yeah.
I think you are not limiting the CPU because it was using maxed up by default is 0 means it's utilizing all the
All the
CPUs on that.
CPUs,
So
all the
CPU
CPUs.
was all the.
So that is the reason I said Blitz who will be having slight advantage over who is active, because I know the problem is with parallelism. Because I will be able to get that information only from Blitz who. That will not be there with SP who is active. That is the reason I said if you are allowed to make use of Blitz tools, just make use of them happily, because that is the best tools that you can analyze your issues. And if you are allowed to run SP pressure detector like Eric Darling tool also, I mean just a script, that is also handy. But still, when it comes to Blitz, there is no other scripts that can provide advantages for DBA. That is top notch. So coming down.
Yeah, you can get those info from the weight types as well, right?
Yeah, yeah.
In the DMS. Okay.
So now if I execute this, okay, it's maxed up 1. Now if I see the parallelism issues are no more, and currently the CPU is just 10, 11. Can you see this in front of you? Now you know this problem has occurred purely because of my max top settings. Because I have not set anything, it's all with zeros, like max top is 0 and cost threshold for parallelism is 5. That is the reason this query is prone to parallelism. Okay, so it will not go well with parallelism. And since I added max top 1 hint now, all of a sudden from 100% CPU, we are down to just 15%. But still we have problem with memory. Okay, still we have problem with memory. I'm not saying our memory issue is gone. We still have problem with memory. Okay, and if I execute this query in 4 different windows, you will see resource semaphore back again. So let me do this. Let me show you that again.
So now we are limiting those individual queries to utilize only one CPU and not spread over the other CPU process. Sorry, to avoid the CPU pressure, right?
Yeah. So now I am running 4 windows. Okay. So now if I go with SP who is active, there is or else even this query can help you get that information. So one query is waiting. One query is waiting. 3 of them are currently running. And even now one query is waiting, as you can see. Where is SP who is active? Yeah. If I run this, there will be one resource semaphore, and other of them are not waiting for parallelism. Now it is waiting for page avalanche. And if I run SP blitz who now, Let's get the output from Blitzu, because as I said, that is advantage if you use Blitzu. Come on. It will be slow compared to SP who is active. I'm not saying that it will be as fast as who is active, but the advantage is it you will be able to get the previous weight types associated with that query, which is not possible with SP who is active. It will take time. So that is the reason I said try to go with SP who is active. But if you have any performance issues and if you need to find out what went wrong with any particular queries, then you can use SP Blitz. See, resource semaphore waits. Because of that, even SP Blitz who is having problem. Whereas SP who is active, it will run instantaneously. See, that is the advantage. Okay, let me stop few queries. Okay, even if I run 3 queries, CPU C is just 35%. It didn't go to 100% like what it went previously. Okay, now you are able to understand parallelism and this memory together. Okay, let me stop this. Stop. Okay, I'm closing these 3 windows again. So what should I do as a DBA now? Tell me that first. We'll see this later. Okay, this query will execute again for 15 minutes or so, or maybe 10 minutes if I use max stop hint 1. So what should I do now? So I will stop executing this just by looking at the execution plan. Can you tell me what can I do to overcome these issues what I have? Because this is what happens in real time. You cannot execute that query, right? Because if you execute that query, it runs forever. Just looking at the estimated execution plan, we should be able to detect where the problem is and how to create our indexes. And unfortunately, we are not even getting any missing indexes hint also.
Vamshi, it's going with index scan here, which should be index C.
Where post or users or post or words. Which
on the
table?
top.
Towards right, yeah.
Yeah, PK.
Okay, so you want some index on post, okay, and what else?
Then, and then in the bottom of the table spool is there now.
So look at, like forget about scan or seek. Just by looking at the picture, can you tell me where the problem is?
The first one only sorting option. 83% is there, na sorting.
So this part,
yes,
right? Everyone is with this part. Or any other deviations?
Table spool. We should avoid aggregator if possible.
Okay, someone is saying table spool and some are saying. So looking at the cost, we can clearly see that this sort and scan is the problem, right? 18, 83 and 13. 96% is being spent here itself out of 100.
Correct.
Yes.
But in reality, this is not the problem. The reality problem here is here. Okay, just don't blindly trust your cost operators. Okay, because we are just dealing with estimated execution plans. Never ever, I mean, it's not recommended just to trust these operators. Okay, cost associated with these operators. The problem is this part. Can you see this thick fat line? Very, very fat line. This is also fat line. I'm not denying that. But after that, we got thin lines. But here, reading the odds table is the problem. And also, after that, I'm getting lazy spool. Okay. And why I'm getting these fat lines? Because can you see the estimated number of rows that I need to read? I mean, read that data size. It is 1.8 GB. That is the same memory grant what SQL has allocated for us, 1.7 something, right? So this is the problem. So the problem is with these thick lines. Of course, when it comes to cost, these two are projecting up as high, but in reality, the problem is here. Okay, the problem is here. So how to avoid this now? What is the right index that I have to create to overcome the problem with votes table? Looking at the query, I have
non-clustered.
Yeah, I have to create non-clustered on post ID column. Okay, so now let's try to analyze the indexes. What I got. Oops. Must be Blitz. Okay, can I go with help index or Blitz index? Which one you need? Your choice. Because I'm huge fan of
Blitz index on.
So if I go with the help index, which is available on all the versions. So I do have post ID as the component, I mean, as the column here, but to generate this workload and to mimic this problem, I disable that index. Okay, so if I wanted to create index, so how I can create the index? So on what basis should I create the index? Because if you see here, when you see out, I think I have explained the eager spool already. This is table spool. That is different from eager spool. In my previous sessions, I explained eager spool, but this is table spool. If you see the output list, it is showing me as votes.post ID. Okay, so I have problem with my post ID column. So I have to create non-cluster index on that column. So once I create non-cluster index on that column, yes, I do have non-cluster index, but I have disabled that index because if I enable that, will not be able to see that issue. So let me copy this and let me enable that index. Is there any command like enable index?
Need to rebuild on.
Yeah, there is nothing like enable, just you have to go with rebuild. So once I rebuild this index, let me go with the statistics profile on. If I don't do this, then I don't know how many pages are being, I mean, how much percentage has been completed. So what is that query? Just type Solomon Rutsky index progress SQL server, or you can use my blog also. It's your choice. Both of them are same. I copied from this uh, article, so I'm just using the same thing. So it's finished now, almost. I think for index rebuild,
I think index creation it does.
yeah, index creation it does, but rebuild it won't. Okay. We have to wait for this operation to get completed. Once this gets completed, then if I run that query, that will get completed in 2 minutes 50 seconds because I tested it. I know how much time will it take. And even after that, will still have problem. Okay. So don't get, I mean, just by creating the index, that is not the case. Okay. It is completed now. So now if I run this query again, okay. So can you see the memory usage? It was 1.7 GB, right? So I'm running that query again. I have to set this off, otherwise it will make mess. It will get completed in 2 minutes 50 seconds, but the problem is it is still taking 1.7 GB. So if I run, see 1.8 GB. So if I run the same query from different windows, now see memory usage is still same. Of course, CPU, we don't have any issues because we created that max top one hint. We are using that. So now let me go to another window, run this, another window, run this, another window, run this. We still have a problem. So if I run SP who is active, so resource semaphore wait is still there. Means one query is not able to get the memory. We know because more than one, it won't run, right? So still we have problem. So what should I do to eliminate that problem? Because this query is taking 1.8 GB of RAM. That is my problem. If I run this query, it is taking 1.8 GB of RAM. I have to get rid of that. What should I do now? Anyone knows how to get rid of that 1.8 GB
We
consumption?
need to avoid the sort operation.
Yeah, we have to get rid of this guy. So we don't have any index now. I'll stop this because it takes 2 minutes 50 seconds. I have to finish this up. So I'm showing the estimated execution plan. Can you see this now? Once I created that index, the big fat lines disappeared. The big fat lines, what we got is now no more, but we have just one operation here. This scan and followed by sort. So once we eliminate this, our problem is resolved. So how to create index here? I am not getting index, missing index DMVs here. If you see here, there is no missing index DMV. It's all up to us to create the right index. So what index should I create here? On post table. Currently, that is what I got. So I will show you the post table indexes. Of course, I created the index, but I disabled it. Okay. So now you have to create index. Okay. You have to create index on partition by column. Okay. Whenever you see this Windows functions, my index usage is something like you have to create index on this column first, means partition by column, and then order by column. So here the partitioning is happening on owner user ID. So that will be my leading column. And then my partitioning, after partitioning, I'm doing order by, and I'm doing this on score. So I created this index. Where is that? So can you see this? Create index on host table. Owner user ID is the leading column, and score descending as the second column. So once I enable this index, then you will see how our problem gets resolved. It's all, end of the day, it's all about understanding what the problem is, understanding the execution plan, and creating the right indexes. So just wait for it. And once that is done, you will see how quickly that query runs. It was running for 40 minutes at the beginning, and still we were not able to complete that. After that one index on host table, it's down to 3 minutes, I can say. I didn't show up because 3 minutes also, it will take some time for me. So once this gets completed, you will see how fast this query runs. Just wait for it to get completed. Any questions now?
So for does it not come with the parallelism appropriate setting as well? Let's say what you are changing on the server level for the maxed up. Let's say, for example, you have 128 or 256 processors and like 3 terabyte or 2 terabyte of RAM on that, right? And then you have a maxed up setting on the server by 8 or 24 or 16. So you need to adjust your parallelism accordingly, cost threshold parallelism.
See,
does that not affect performance?
Yeah. So whenever we are tuning a max stop, okay, you have to go it at query level. Don't touch the instance level max stop. Okay. Don't touch the instance level max stop, because we don't know how different queries perform, right? So it's not recommended to touch or tweak something here. You have to do tweaking at query level, like what I am doing. Okay. If you
But
are
in
not,
real, go ahead.
yeah, if you are not allowed to change the code, okay, if you are not allowed to change the code, because there are vendor databases where we cannot touch the code. Okay, if that is the case, instead of tweaking at uh, uh, query level, at least you can change for that particular database, because even at database level, we have something called as database scoped configurations. Okay, I think this will not come because we are currently doing this operation, right? Sometimes these logs and all are incompatible. So I will show you for other database. So there is something called as max stop. Okay, try to tune it for that particular database, not at instance level. If you are having problems with that DB, just try to do it for that DB. So where is that option, max stop? Yeah, can you see this?
Yeah.
And even if you are not allowed to, okay, just imagine this is, if you are allowed to do something from query store, you can use query store also. There are something called as query store hints from 2022. You can use that as well. The last and the least option is trying to change at server level. I don't encourage at server level, because different databases performs differently. And if you tune this at server level, every query will try to make use of this setting, and that will be a problem.
Yeah, so it's only the query. I mean, yeah. So not all of the query from the application have those query hints on option maxed up, right?
Yeah.
So sometimes you need to adjust on the server level, and then when you put it in the
not
query
server
level,
not server level, DB level. Just make the terms correct. DB level. Just do it at DB level. Don't go with server level. Don't go with server level. I'm saying it again. Go at least at DB level for that particular DB. That's enough. You are not touching the other databases. Now, finally, if I run this query now, it was running for 40 minutes, right? Run this now. How many seconds? How many seconds? 0. So that is the power of understanding the execution plan, understanding what is resource semaphore, and how to, create, overcome the problem. Now, if I run these 3 queries, so if you see the memory grant for this query, it is just taking, let me go to that memory grant, how much it is taking. I think it will be null, if I'm not wrong. Means it is not at all taking anything. See, 0.
It's the magic of right index, I guess, right?
Yeah,
in this query.
It's the creation of right index. It's understanding the resource semaphore and how it works, and tuning our query to overcome the parallelism also. So from 40 seconds with 100% CPU, we are down to 0 seconds with no amount of CPU. Of course, this 96%, that's you can leave this aside because we don't have any problems with this query now. Even if I run this parallelly from, let me open my query stress, and if I run this, it will work because I will not have that memory grants issue. Let me copy this query. So last time I think I went with how many threads? 5 threads and 7 iterations, or 3 threads something.
Five. Yeah, 5.
Okay, let me do that again. Server. Five iterations and 7 threads, I believe. Boom. So I'm running this. It's completed. Completed. Iterations 5, 7, 35 completed. See, that's the power. That's the power of understanding the concepts. Okay, creating the right indexes. We are done with resource semaphore problem. As simple as that. Once you know where the problem is, you can sort this out. And I was expecting one question, but no one has asked that question. At the time of index creation, can you see my index creation? I said score descending explicitly. Usually we don't do this kind of index. We'll just say the column names, owner, user ID, and score. But here I said explicitly score descending. Why I said score descending and why it is explicit, in the upcoming class I will tell you.
Okay.
Of course, we are doing this here, P score descending, because our indexes are cluster indexes and B trees, they are internally linked list, double linked list. Even for your information, if you are from computer background, you know that single linked list and double linked list, right? So ours is double linked list. So why should I specify score descending? Why not just score? We'll explain that later. Did you find this class interesting before I shut this off?
Yeah.
Yes.
Yes.
Okay. So
Very
this is
interesting.
just the beginning. Okay, we have to go a bit deeper. As I told you, there are 4 questions that were unanswered. So I will explain them in the upcoming memory sessions. I have to run now because it's 5:30. I have to close this off. Any questions, you can ping me on my WhatsApp and I will upload the session right away after 20 minutes.
Once the scripts both, you can upload it. Scripts
This
also.
big query, what I've shown, right?
Yeah, this one, and as well as you have used your own, right? Small.
Own, yeah.
Which one?
The other one.
Yeah, all these small queries.
Okay. Small queries. Yeah, we'll do that.
Yeah, all these are the small, we can understand also sometimes.
Okay. Sure. Yeah.
We'll try to mimic this. Yeah.
Okay, guys. Thank you. Thank you for your time.
Thank you.
Thank you, Vamshi.
Yeah.
Bye.
Vamshi?
Thank you, Vansi.
Bye. Yeah.
So how much we have to keep that maxed up if you are running on a database level?
It depends upon your weight types. Okay. And can you ping me on my WhatsApp because that will be easy for me. I can explain it there. Yeah.
Okay. Right. Thank you.
Thank you.
Thank you,
Yeah.
Vamshi. Thanks for valuable.
Thank you, Vamsi.
Yeah.